Okay, and we have two theories of the acids and bases, Arrhenius and Brønsted-Lowry. So an acid, according to Arrhenius, is something that produces hydrogen ion in solution. H plus is acid. That's what it is. Okay? It's a proton that goes around and it protonates things. It reacts with stuff. It's very reactive. And so that's why acids are very reactive things. Bases, you get hydroxide in solution. Okay? So if something has a hydroxide on it, it would be a base because it would donate that hydroxide to the solution. And then you'd have hydroxide. They need to be OH. The polyatomic ion hydroxide, OH minus. That's what it needs to be. Okay? Okay, now the problem with this Arrhenius theory is that NH3, which is a base, doesn't really fit into it. Okay, because there's no hydroxide on NH3. So why is it a base if there's no hydroxide on it? Well, it's because when you react NH3 with water, NH3 plus H2O, okay, then it produces NH4 positive plus OH minus because the water donates a hydrogen to the ammonia. So we develop a new theory of acids and bases, and that is the definition of a base is a proton acceptor. And an acid is proton donor. That's spelled donor. Whoa. That's bad. Donor. Okay. So that's the acceptor, that's the donor, that's the acid or base. That's how we will describe them. Okay? As either something that grabs the hydrogen, which is a base, or something that gives the hydrogen away. So looking at this example, which one grabs the hydrogen? That's why it's a base. Which one donates the hydrogen? Okay, that's why it's the acid. Okay? So water can be an acid or it can even be a base. It depends on what you're reacting it with. If you react it with a base, then it's an acid. If you react it with an acid, then it's a base. But the base of the acid is what's causing the acid to become acidic or basic. It's in the reaction with. Otherwise, it's neutral, neither an acid or a base. Or you can consider with the autoionization, which we're going to talk about in a minute, it kind of does both. Okay, so here, donor and acceptor, those are acids and our bases. That's how we're going to define them. So here, hydrochloric acid, if we react it with water, now you can see that water is the base because hydrochloric acid donates a hydrogen to water. Water becomes H3O+. Now remember what I told you. Or maybe I told you. H3O+ and H+ are exactly the same thing. They're synonymous. So if they say, how much hydronium ion, what is the concentration of hydronium ion? That is the same as saying, what is the concentration of H+? It's synonymous. It means the same thing. If they ask you, what is the pH? That can be discovered through the concentration of H+ or H3O+, because they are the same. Okay? Okay, so in here, this reaction, what donated the proton? HCl. HCl is therefore the acid. What accepted the proton? H2O. So it's the base. Okay? So depending on what you react it with, water is either an acid or a base. And pretty much anything. If you have two acids, one stronger than the other one, then that weaker acid would actually work as kind of the base in that reaction, because it's a weaker acid than the other acid. Okay? Okay. So here's NH3 again. You can see it goes to NH4 plus and OH minus. NH3 is the base, H2O is the acid in this case. So water possesses both acid and base properties. We say it's amphiprotic for that reason. Okay. So the strength of acids is dependent on the degree of ionization or how well the hydrogen comes off. Does the hydrogen come off 100%, or does it come off only partly and then go back and forth, back and forth? If it goes back and forth, it is called a weak acid. If it comes off 100%, it is a strong acid. And strong acids are strong electrolytes because they dissociate 100%. 100% of the hydrogen comes off. It doesn't set up an equilibrium. So when we write it, like HCl, which is a strong acid, we would say it becomes H plus Cl minus because this comes off 100%, no double arrow. Whereas with NH3, which is a weak base, we do produce plus water. We do set up an equilibrium. NH4 positive plus OH minus. This is a weak, it's because of the equilibrium, the double arrow. Okay, well there are some tells, so let's see if we get to that. Here, some strong acid, this would be some strong acids, HCl, HBr, HI, so halogens, Cl, Br, and I. Those are strong acids, except for which one? Fluorine. HF. HF is the only weak acid of the halogens. Okay? Now, look at nitric acid. It's a strong acid. Why? Because of all the oxygens on it. 3 oxygens, 1 hydrogen. So that ratio, 3 to 1, forces that hydrogen to be able to fall off easily. Because all those oxygens are pulling electrons away from that. It's an area and it becomes H plus very easily. Okay? Same thing here. H2SO4, lots of oxygens, 2 hydrogens. Now only one of these hydrogens actually is the strong hydrogen that comes off. So it goes from H2SO4 and in a strong acid step becomes HSO4 minus plus H plus. Because that hydrogen comes off 100%, the first one does. Notice the second one didn't come off. The second one sets up a weak acid equilibrium. In a second step where it's HSO4 minus, in a weak acid step becomes H plus SO4 2 minus. Okay? So the first hydrogen of sulfuric acid, strong hydrogen. The second becomes a weak acid. Okay? HClO4, lots of oxygens, 1 hydrogen, strong acid. Okay? That hydrogen is going to fall off. Metal hydroxides. So basically a metal with a hydroxide, it's going to be a strong base. The weak bases are the ones that don't have OH in them, like NH3. NH3 doesn't have OH. There's lots of weak bases that don't have OH in them. Okay, weak acids and bases dissociate only partly, so therefore they are set up equilibrium. Here's an example of a weak acid that sets up an equilibrium. Acetic acid, which is vinegar. So the stuff in your cupboard at home. Acetic acid creates an equilibrium between acetic acid and the acetate ion. Acetic acid and acetate. This is the acid. Okay, water is working as the base here to produce acetic acetate and H3O plus, which then this becomes the acid in the reverse direction, right? The hydrogen donor, this becomes the hydrogen acceptor, in the reverse direction for the equilibrium, and they set up an equilibrium. Okay, so weak acids. So we have weak acids, we have strong acids, but just because it's a weak acid doesn't mean that you should make fun of it. I know, poor guy. Poor weak acid. Okay? No, weak acids are very, very important. So, for example, this one right here, H2CO3. H2CO3 is carbonic acid, which is the acid base bicarbonate right here situation in your blood. No? No, not that important. Your blood has to be maintained at a pH of 7.4. If it's not, guess what happens? You're dead. You're dead. What's that? Yes. Okay? Your body has to maintain homeostasis of your blood pH at 7.4, right? So if it doesn't do that, you're a goner, because your proteins, they don't work at other pHs.
What would make your pH go up or down?
Well, lots of things, but your body takes care of it all the time. Why? Because when you have a buffer system, what happens is that this base, if I add extra acid, then the extra base here reacts with it and pulls out the acid and turns it into this. Whereas if I add extra base, it reacts with this acid and it goes this way. And you pull it out and you maintain your buffer, the pH of your blood, through a buffering system. This is a buffer system. So weak acids and weak bases create buffers. Strong acids and strong bases cannot. They can't do the back and forth. So if I have a strong acid, I can only react it with a base. I cannot react it with an acid and bring down the pH. So weak acids and bases can maintain the pH at very specific levels. Okay, they resist changes to the pH. So very important, right? We live by it. Literally, yeah. We live by the weak acids. Okay, here's some weak bases. You'll notice they don't have any OHs in them, but these are a few examples of some weak bases. Ammonia, pyridine, aniline. Okay, they all accept a hydrogen from water, and they become this. And what's left over? OH minus, because water lost one hydrogen, so it produces OH minus. Okay, conjugate acids and bases are simply what we say, here's the equilibrium. So if this is the acid, and it becomes this, well, now that thing over there is the base. This is the base, going backwards. And if this is the base, it creates the acid. It's always like that. An acid becomes a base, and the base becomes the acid on the other side of the reaction. Now, on this side of the reaction, we call it the acid base. On this side, we call it the conjugate acid and the conjugate base. That's the conjugate acid, that's the conjugate base. So if this is the acid, its conjugate base is this. Okay. Yes. 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 Okay. We're going to see that. We're going to look at that in just a minute. We'll answer that. We're going to pull up a chart that kind of shows that. Okay. But good observation. Okay. So here we have the acid bases. We've labeled them once again. Okay. When only one arrow is used, there's no reversible, so we don't really say there's a conjugate acid or a conjugate base of that. Okay? All the HCl is converted to Cl minus. This is a strong acid, 100% dissociation. Weak acids don't dissociate 100%. They set up an equilibrium. So here's that chart I was just saying. So you'll notice that on this chart, okay, we have some weak acids which are stronger than other weak acids, right? Not all weak acids are created equally, okay? So we have HF, which is stronger than H2PO4. This is a stronger acid than H2PO4. Why? Because the conjugate base of HF is F minus. So looking at F minus, where it lies on here, F minus is actually a fairly weak base. So because this is a strong weak acid, it creates a weak base. The back and forth means that it's a stronger acid than it is a base. However, down here, for NH4+, NH4+ becomes NH3. NH3 is a fairly strong weak acid base. So the weak base here is stronger than its conjugate acid. So the back and forth, the reason it's a stronger base is because its acid is fairly weak. So it wins the competition. It's winning. Yes. The strongest bases are the weakest acids. The strongest acids are the weakest bases. Okay? What's that?
Is there one that's just equal?
Right here. These ones that are kind of in the middle, they so like bicarbonate and the one that we talked about for our blood, that's around a pH of 7, which is a pretty neutral pH, right? It's fairly close. That's why this works. And both of them are fairly strong on both sides of the reaction. So that's why it's around a pH of 7, because it's neutral. Okay? So the acid is about as strong as the base, and the base is about as strong as the acid. In that case.
That's the one in our body.
That's the one in our body. That's the one in our body. And that's how we transport carbon dioxide out of our blood. Because the carbon dioxide dissolves into our blood, becomes carbonic acid, and then when it gets to our lungs, it goes back, turns back into carbon dioxide, and then is exhaled. So our bodies do pretty amazing things. All right, so let's try to write some reactions here. HF, a weak acid. HF is going to dissociate. It's a weak acid, so double arrow. Weak acid, double arrow. Strong acid, single arrow. Weak base, double arrow. Okay? All right, so HF is a weak acid. It's going to dissociate into what? What does it become? F minus plus H plus. Okay? What is this one going to become? Only one of the hydrogens comes off at first. You might set up a second one later, but just the first one. That's all. H plus plus HS minus. And then this one might set up a second equilibrium and go farther to S minus. That's 2 minus. What's that? Yes. Because there's 2 hydrogens. So everything that has more than 1 hydrogen has to do 2 steps to get rid of both of them. Okay? Absolutely. H3PO4 has 3 steps to remove all 3 hydrogens. It would be in equilibrium with H plus plus S2 minus. That would be the second step. Okay, HNO3, strong acid. So single arrow, H plus plus NO3 minus. This is a base. What do bases do? They gain a hydrogen from what? And what is the acid in this case? Water. Plus H2O. So when you write the base, you always need to include the water because that's where the hydrogen is coming from. Okay? In the base step, that's where the hydrogen comes from. So CH3NH2 becomes CH3NH3 positive because it picked up a hydrogen, right? Plus OH minus because the water became OH minus.
How did you?
Water's the acid.
Oh,
That's right.
So we say always add the H2O.
Always add the H2O.
And then the product.
Because that's where this OH minus comes from. It's from the water.
Okay.
So you have to include the water in that reaction. In these ones, you don't have to include water. I could have put plus H2O, and then this would have just become H3O plus NO3. But remember what I told you, H plus and H3O plus are the same. They're synonymous. Use them as though they're the same. Okay?
And when you add the H2O, it's always going to be the OH minus on the other side.
When it's a base.
When it's a base.
When you add the water, it'll become OH minus because the water is what donates the hydrogen. Yeah. Okay, so water actually, pure water, will react with itself. Okay? So one water molecule finds another water molecule, they react, and they form H3O plus OH minus. Okay? This is called the autoionization of water. Water is a very, 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 very weak electrolyte. It doesn't really conduct electricity. Okay? You have to have molecules dissolved into it, electrolytes dissolved into the water to cause it to conduct electricity. But on its own, it doesn't. Okay? Because it only forms small amounts of each of these. It will not conduct electricity at all. Good luck. Yeah, done it many times. Okay, but then you dump some salt in it, and all of a sudden it does. So the reason water conducts electricity from your faucet is because there's all kinds of ions, minerals, and things dissolved into it. Okay, from the aquifer. So here, the concentration of H3O plus that is produced from water autoionization is 0.00000001. Here it's so these are the same number. That's what I produce for autoionization of water. And that number actually in scientific notation is 1 times 10 to the negative 7. 1 times 10 to the negative 7. You're going to see why that number is important in a minute. Okay? But those are the concentrations. Oh, they wrote them here. Okay? So 1 times 10 to the negative 7 are the concentration of H2O plus and OH minus in solution. Now, if I was going to write the KEQ for the autoionization of water, H2O liquid plus H2O liquid produces, KEQ is equilibrium constant, produces, I should just write it, H3O plus aqueous plus OH minus aqueous. Now, KEQ is equal to the products over the reactants. Okay? That's something you guys need to try to remember. The products over the reactant. So if I write my KEQ correctly and they tell me the concentrations, I can calculate the KEQ. So, which is equal to, in this case, the concentration of H3O plus times the concentration of OH minus raised to their coefficient. But they don't have any coefficients, they're all 1, so I don't have to raise it to anything. Divided by the reactants. But look at the reactants. What's the physical state of the reactants here? They're liquid. And when I have a liquid, I do not include it in my equilibrium constant. So simply the KEQ is equal to the concentration of H3O plus times the concentration of OH minus. This is the equilibrium constant for water. And I told you what the concentrations were. They're 1 times 10 to the negative 7 and 1 times 10 to the negative 7. 1 times 10 to the negative 7 times 1 times 10 to the negative 7. The KEQ, which we're going to change to call the KW because it's for water, is equal to 1 times 10 to the negative 14. You're going to start to notice some trends right here between negative 14, negative 7, and the pH scale. What's the highest number you can go to on the pH scale? 14. What is a neutral pH on the pH scale? 7. Okay? You guys are going to love pH. It's so easy. It's amazingly easy. pH is a measurement of the acid in solution. It's measuring the acid. Okay? And this is the equation to calculate the pH. The pH is equal to the negative log of the H plus ion, or the H0 plus, whatever they give you, the same thing. Okay? The negative log of the H plus ion of the free hydrogen in solution. That's what the pH is measuring. So, get out your calculators. I want you to find the LOG button. The log button. Find the log button. Because for pH, that's the one we're going to use. Yeah. Oh, I just put H plus. H plus and H0 plus mean the same thing. That's all I'm trying to say there. Okay? It's H0 plus. Or you can say H plus. Either one. Okay. So, if I know the concentration of the hydrogen ion in solution, then I can easily measure or calculate the pH. Okay? So, if I have an H plus concentration equal to 0.0086, then the pH equals what? Okay, well actually, you know what? Let's start somewhere even easier than that. We'll go back to that one in a second. Let's say the H plus, this will be easier. This will kind of set it up for you, is 0.00001. If I write that number in scientific notation, that is 1 times 10 to the negative 5. Okay? What is the pH equal to? So, on your calculators, everybody's calculator is different, or, well, I mean, not everybody's, but part of you are going to do it one way, the other part of you are going to do it a different way. So, some of you are first going to hit the log button on your calculator, LOG. And then it goes log, parentheses, and then you put your number there, okay? Others of you will actually have to put the number in first and then hit the log button. Okay? So, if you hit log right now and it tells you error, then you need to put the number in first and then do the log. But if you hit log right now and then it gives you parentheses to put the number in, then you're ready to put this number. So, do that. Hit log, doesn't matter. Both of these will give you the exact same answer because they're exactly the same number. Okay? What is the log of 1 times 10 to negative 5? No? Close. No?
Would you put the negative?
Negative 5. But we're not doing the pH. The pH is 5. But what is the log what is the log of this number? The log of this number is -5. Okay? The log is -5. It's right there. There it is. The reason I don't have to use a calculator is because this number is 1. But if I change it to a different variable than 1, then I can't just say the log is -5. It changes, okay? But because it's 1, I can say the log is -5. Now, if I take the negative of that -5, it becomes what? +5. So my pH is 5.
Because of the negative in front of the log equation.
You get rid of the negative sign. Drop the negative. pHs are always positive. Okay, because the equation is the negative log of the H plus concentration. So the H plus concentration is going to give you a negative log, and then you take the negative of it, and it becomes a positive. Okay? Or simply remember, drop the negative. pHs are always positive. pH is 5. Okay? So, what is the pH if my solution H plus equals 1 times 10 to the -8? pH is 8. Do you guys love pH? Okay, good. Okay, so pH is 8. What if the pH equals 12? What is the hydrogen ion concentration? There you go. Okay, 1 times 10 to the -12 if the pH is 12. Now let's go back to our earlier example. If the H plus is equal to 0.000865, what is the pH equal to? So that number in scientific notation is 8.65 times 10 to the -4. Okay? So, what is the pH?
2.065.
Has to be something more around 3 because the log is -4, so it's got to be around 3. You hit log on your calculator and then type that number in, hit enter, and it's going to give you a negative. What did it give you? -3.1. Okay, 3.6. So you get a -3.6. You drop. Okay, you guys are way too picky about it. Okay, 3.1, 3.06. It is almost exactly the same. It's okay. Okay, we're all right. We're okay. Everybody's doing it right. You drop the negative, and that's the pH. So pH equals 3.06 or 3.1. Okay? All right. So that's what we get. Okay? Now, this is the next thing we have to learn. So that's easy. Going to pH from the H plus to the pH, that's easy. Okay? Now, going backwards has always been a little more troublesome for people. Okay? So, what you need to remember is that when you're going backwards, you have to remember to put the negative back. Okay? You have to put the negative back. So, to go backwards, you use this thing called the anti-log. And the anti-log is the button right above your log button. It's 10 to the x. Okay? So find the 10 to the x button. Yes, it's usually a shift log function. Okay? So, and what you're going to do is you're going to put 10 to the -3.1. Okay? So how you enter it into your calculator varies, but some of you are going to have to hit the anti-log button first and then put -3.1. Others of you will have to hit the put -3.1 and then hit the anti-log button. But you're going to be able to get back to that number. Okay? Did you use 3.1? Sure. Use 3.06. I mean, that's close enough, but go ahead. 3.06, try that one. Okay, so, okay, you're getting back. That's how you go back and forth. This is what I have my kids do for fun. Log, anti-log, log, anti-log. Okay, I'll help you. All right. Okay, so let's try another example, and I'm going to go back there. If the H plus equals 1 times, actually 3.6 times 10 to the negative 11, the pH equals what? Okay, so what's the pH? 10 point what? 44. Okay? 10.44? I calculated it because you guys are always arguing about the answer. Okay, so 3.6 times 10 to the negative 11 log 10.44. Good. Okay? So that's my pH. Now, here's something that we need to consider. Okay? When our H plus ion concentration is increasing, guess what's happening to our OH? It's decreasing because H plus and OH minus are always in equilibrium. They always equal 1 times 10 to the negative 14. That's the KW. So they are in equilibrium, so if one goes up, the other must go down. If the other one goes up, then the other one must come down. Okay? They are always working against each other. Except at a neutral pH. Then they are equal. 1 times 10 to the negative 7 would be a pH of 7. Right? 1 times 10 to the negative 7 is a pH of 7. pH of 7 is neutral. If it's 1 times 10 to the negative 7, the concentration of H plus and OH minus are exactly the same. But as I go down from the H plus, so let me show you. So pH 7. If I go up 8, 9, 10, 6, 5, 4, okay? Well, if my pH is 7, then my POH is also 7. Well, what is POH? POH is the negative log of the hydroxide OH minus concentration. Here they are equal, so that's why this is neutral. Well, if I go to a pH of 6, which means my concentration is 1 times 10 to the negative 6, right? What is my POH? 8. Good. 9. 10. 6. 5. 4. What do these always add up to equal to? 14. Right? So the pH plus the POH always equal 14 because they are always working in conjunction. They're always at equilibrium. 1 times 10 to the negative 6 times 1 times 10 to the negative 8 equals 1 times 10 to the negative 14. They're always in equilibrium. Okay. All right. So I can if I know the OH minus, that means I can calculate H0 plus, or if I know the H0 plus, I can calculate the OH minus. Okay? I can calculate one or the other. Because if I know my pH, I can find my POH, and if I know my POH, I can find my pH. Okay. we're good with that. Now, here's another little idea that we need to focus on. If they give you the concentration of a strong acid, what is the pH of a 1 times 10 to the negative 4 molar HCl? 1 times 10 to the negative 4 molar HCl. Well, HCl dissociates 100% into H plus Cl minus. So that means the H plus is 1 times 10 to the negative 4 molar, and Cl minus is 1 times 10 to the negative 4 molar. Because it dissociates 100%. So if they tell you the concentration of a strong acid, then you know the concentration of the the H plus ion that has been produced. It is the same as the concentration of the acid. So what is the pH of HCl? 4. So HCl solution that is 1 times 10 to the negative 4 molar will have a pH of 4. Okay? So if it's a strong acid and they give you the concentration, they're not going to give you the concentration of a weak acid because they don't expect that you're going to be able to do the calculations required to calculate the pH of a weak acid. Okay? Because we're not going to cover that. Which we wouldn't say pH is so easy if we did. Okay? So, and this is a terrible slide. What is the H2O plus of a solution with a pH of 6? And then they change it to 4, just like randomly in the middle. Okay? So if it was a pH of 6, it would be 1 times 10 to the negative 6. If it's a pH of 4, it's 1 times 10 to the negative 4. Okay? So, not sure how they got that confused. Good. What is the pH of a 1 times 10 to the negative 3rd molar potassium hydroxide solution? 1 times 10 to the negative 3 KOH. What do I do?
Break it down the way you did the H.
Yeah. So what is it going to produce in solution? Okay. What is the concentration of the OH minus in solution? One times 10 to the negative 3 molar. Okay? What the question wants me to answer what question? What is the pH? No. The POH is what?
3.
3. POH is 3. So what is the pH? 11. Thank you.
Oh, the people first.
That's right. Because what did we produce here? OH minus. If it had been that I had produced H plus, if this was H plus instead of OH minus, then the pH would be 3. But it's OH minus. So from the OH minus, I can find the POH to be 3, which means my pH is equal to 11. Okay? 14 minus 3 equals 11. Okay? Because the POH is 3 and the pH must be 11 because POH plus pH equals 14. Okay? Yep. But it's simple addition and subtraction, right? Okay? Yep.
I'm a question. Could you go over the part where you break it down, like the KOH and then it's K plus OH minus? How would we know? Like, can you give another example of the different compounds? Like, how do we know what to break it down to?
So 1 times 10 to the negative 4 molar sodium hydroxide. Once again, it's a strong base, so sodium hydroxide is going to break up into sodium plus OH minus. It's 100% dissociation because it's a strong base. So the concentration of sodium is 1 times 10 to the negative 4 molar, which for our purposes we don't care about. Sodium's a spectator ion, doing nothing. What we care about is the OH minus, 1 times 10 to the negative 4 molar OH minus. So what is the POH? 4. Because it's 10 to the negative 4, so it's the POH is 4. The pH, therefore, is 10. Okay? The pH is 10. Okay? And pH. pH and POH. POH is for OH minus. pH is for H plus. Okay? P stands for the negative log. Negative log. P stands for the negative log. So if I asked you to find the negative, if I asked you to find the pKa, then what do? If I said, what is the pKa? It doesn't matter what the Ka is. What is the equation? The negative log of the Ka. Because P stands for the negative log of. Alright? The negative log of OH minus. The negative log of H plus. Okay, so let's do some more examples. What is the pH of a 2.5 times 10 negative 4 molar HNO3 solution? HNO3 is a strong acid. 2.5 times 10 to the negative 3 HNO3. Why don't you go ahead and tell me what the pH is and the POH?
HNO or something. That means there's no
So if I give you one thing, if I give you the pH or the POH or the H plus or the OH minus, you can find everything else. Okay? And there's always 2 ways that you can do it. So if I give you the pH, from the pH you can find the POH, and it's simply 14 minus the pH to find the POH. If I give you the POH, you can find the pH because it's 14 minus the POH. If I give you the pH, you can also find the H plus ion concentration because it's 10 to the negative pH, or the anti-log of the negative pH, okay, to find the H plus. If I give you the H plus, you can find the pH by taking the negative log of the H plus ion concentration. The POH to the OH minus, same thing. Okay? POH to OH minus, 10 to the negative OH minus, or I'm sorry, 10 to the POH. If I go from OH to POH, then I take the negative log of the OH minus ion concentration. Now, you see how we're missing a gap here? What about OH to H plus? Can I go from OH to H plus? Yes, I can. How? Because 1 times 10 to the negative 14 equals the concentration of H plus times the concentration of OH minus. They're always in equilibrium with each other. So the main thing you need to remember about going from here to here is 1 times 10 to the negative 14 is always on top. It's always on top. If I want to find H plus, I simply take 1 times 10 to the negative 14 divided by OH minus. If I want to find OH minus, 1 times 10 to the negative 14 divided by H plus. 1 times 10 to the negative 14 is always on top. Okay? So if I want to go here to H plus, 1 times 10 to the negative 14 divided by concentration of OH minus. If I want to go here, from H plus to OH minus, 1 times 10 to the negative 14 divided by the concentration of H plus. And I get my OH minus. Okay? We have completed a circle here. So if I am given one thing, I can find everything else in pretty much 2 ways. I have 2 directions I could go to find anything else. Okay? So, let me give you a question and find all the other parameters. Okay, go ahead, write this down, and then I'm going to put back up the reference material. Okay, if the OH minus is equal to 3.65 times 10 to the negative 5, what is the H plus? What is the pH? And what is the POH?